All right, so today we're on notes 11. Finally, got this thing to get to work. And we're going to be talking about some terminology. And so one of the important things to talk about when we're talking about or discussing vectors is the importance of a vector. If you watched Despicable Me, the guy's name was Vector, and he said that he did it with magnitude and direction, right? When he was committing crimes, he was doing it with magnitude and direction. And so it's important that we understand that a vector has magnitude and direction. And so magnitude is basically just the length of the vector. That's always what it's going to be. So how long is the vector is going to be the magnitude. And then the direction is from a starting point to an end point, and it gives us an arrow to be able to tell us which way we're going. So the magnitude is how long, and the direction is which way we're going. So whenever we talk about vectors, we need to have those two things discussed, okay? And a vector is typically, and it'll be hard for me to do obviously when I'm writing, but it's bolded. So this here, it's talking about a vector A, lowercase a, and then the points are from A to B, and it's giving us the direction which way it's going. It's going from A to B, and A is typically called the tail, and B, where the arrow is the head. Just like a bow and arrow, right? You have the tail and the head. It's just like that. Now, when we talk about magnitude, and I'll demonstrate all of this, but magnitude is shown usually with 2 bars, right? So it's usually shown this way with the double bar, so that people don't get confused when you use a single bar, which is absolute, right? So it's important that you get that. I won't use the single bars because I don't want it to get mistaken for absolute value. But you can see it. We don't want you confused, so we use the double lines for magnitude. Okay? Now here, these are some examples of vectors just so you guys can look at it. These vectors, in this first example, vector A and vector B, they are going the same direction, but they're not the same length. And since they're not exactly the same, they're not equal. Vector B and vector A, just the simple fact that they are going different direction makes them not equal. In example 3, we finally have the equal piece because they're the same magnitude, same length, and they're going in the same direction. Okay? So a vector can be equal to another vector as long as they are going the same direction and the same magnitude. They don't have to be in the same place. They just have to be going in the same direction and have the same length. Does that make sense? You guys okay with that? All right, good. Okay, so when multiplying vectors, right, we multiply by a thing called a scalar. And what a scalar does is it's just going to take our vector and whatever that number that we're multiplying by, it's what it's going to do to the vector. So this is our vector that we're given. And so we can see that this 2v is going to be v, but v written twice. So it's going to be the vector going in the same direction, but twice the length, right? Twice the magnitude. The 1/2 v is going to be going in the same direction as the original vector, but it's going to be half the length. Now, one of the important things to stress is if we have a negative scalar, what it does is it makes us go in the opposite direction of our original vector. So in this example here, it's the same magnitude, but now instead of going towards a 45-degree angle, it's going in the opposite direction. So that's all a negative scalar does, is it changes the direction that we're going from. The direction we are pointing, it actually has us go the opposite direction. Are you guys okay with that? Okay. Very cool. Now, when we're adding vectors, the way to do it is this whole head to tail piece. That's how we do it. That's critical that you guys get that. So we have these two original vectors, vector A and vector B, and they're in the magnitude and direction that they're going. And so to add them, what we end up doing is we put our A vector down, and then at the head of A, we put the tail of B, right? And then we end up with the tail of A and the head of B. That's where the result of the vector being added is, that vector AB. Are we okay with that? Okay. Now, one of the things that's cool is if we're going to subtract them. Now, the blacks are the original vectors, right? So if we're going to go A minus B, instead of having it be this result that would have been here, that would have been A plus B, right? This vector here would have been A plus B. But since we have A minus B, we need to go, instead of going in this direction, we need to go in the opposite direction. And so this is our start point, this is our end point, and that yellow is our result. We okay with that? So that's how you add and subtract in vectors. So why don't we try it? Okay? So why don't we try it? So here's some examples. And so what I'll do is I'll use color for each so you guys can see it. So what I'm going to do is it's asking for P plus Q. Okay? So my P is, it looks like it's 1, 2, 3, 4 blocks. So I'm going to go 4 blocks. And then Q is 1, 2, 3. So I'll use blue for that, 3. Right? And then the result is from the tail to the head. So this green is my vector R. Are you guys okay with that? That is vector P plus vector Q. We're good? Okay, let's do the next one. So the next one is asking for 3 vectors to be added. So we're going to do that. So it's A plus A1 plus A2 plus A3, right? So we need to follow that order. So I'm going to go, okay, I'll start here. I need to go diagonally. That's A1. And then A2 is 1, 2, 3, 4, 5. And then A3 tells us to go down 2, so we'll go down 2. And so remember, our result is going to be, ooh, and I should use a different color. I'll use pink. It's from the start's tail to the last one's head. So that means we got to go this way. And this one in pink is RR. This was A3. Are there any questions on these, how I'm doing them? What do you mean by that, Leah? So
like, how do you know how you write them next to the example?
Oh, okay, so watch this. So you see how here my A1 is at diagonal, and it goes 2 squares, right? So when I write that first one, because that's A1, I'm going to go diagonally in the same direction because I have to have the same direction in order to be able to stay true to that vector A1. So it's got to be exactly the same as this guy. So just think of it as I took this A1 and dragged it over into this position. Does that make sense? Okay. Then I'm taking and dragging this guy to the head of A, and that's where my A2 is. And it's still the length of, it's got a magnitude of 5 blocks. So 5 blocks. Okay. Then I drag A3 in that position, and it's still got to keep the exact same position. Now, to get the resulting vector, it's from the tail of the very first vector to the head of the last vector. Does that make sense? Okay, cool. Thank you for asking the question, because, you know, it's one of those things where I think I'm doing it just fine, but it's getting someone to ask a clarifying question just makes it that much clearer for everybody. Okay, let's do the next one. There's another way you could have done this problem too. It's not a big deal. You could have done this guy right here, added these two, and that result would have been this, and then added A3 to it, and that would have gotten you to the same point, right? Because A1 plus A2 is that blue line, but there's no need to get confused with that, so just stay with what I've shown you. That will work. Okay, let's do this next one. So it's saying P minus Q, right? So what I'm going to do is I'm going to start with P, and P is 1, 2, 3, 4, 5. Right, that's my P. And then it says Q, but it's minus Q. So Q is 1, 2, 3 diagonals. But instead of going in this direction with it, I have to go the opposite direction because there's a minus sign in front, right? So then I need to go 3 this way. And that's my minus Q vector. Okay? And so then my result is from the tail of my starting vector to the head of my final vector. And that will be my R vector. Is that making sense? Okay, good. And I'm trying to do it in different colors, that way you guys can see each vector, just to get clarification. It's important that you guys get clarification from that. So, yeah. All right, let's do this next one. Or do you guys want to try it? And then I'll do it? All right, why don't you guys try it and then I'll do it for you. Let me know when you guys are ready for me. Okay, so check this out. So let me do it for you. So I'm going to start with my first vector, and that's going to be B1. So there is my tail. right? And it's going in this direction. Then I need my second vector. That's my B1 vector. Then my B2 is 1, 2, 3, 4, 5 squares. So I'm going to go 5 squares. Right? 1, 2, 3, 4, 5. Yep. That's my B2. And then B3, it's subtracting B3. So we need to subtract B3. So that's going to have us go down. So that's our negative B3, right? And so our result is from the tail of our first vector, so B1, from here to here. So that thing in green is my R vector. Does that make sense, Oscar? Okay, good. So it's always the tail of the very first vector we draw to where we end up in our mapping. Okay? Okay. Are there any questions on that? No? All right. So here we go. Now, standard position for a vector is going to always be in a position where it starts at the origin. So if we were on an XY plane, this thing right here is in standard position because the tail is starting at the origin and then we're having our vector. That's all standard position means. Now, when we talk about component form, you know how we have x comma y for our point on a coordinate plane? Well, in vectors, we think of them as vector 1 and vector 2. So let me draw a picture just so you guys can kind of understand. So let's say that this was V1 and this was V2. The way that it would be done is this is V1, right? Actually, I drew it wrong, so let me fix it. This is V1, and this would be V2. Right? So that vector that we're getting is V1 plus V2, but just think of it as in terms of x and y's, it'd be vector V1 comma vector V2. Okay? So that's how you do the component piece. Now to get the magnitude, this is the magnitude here. So this is a formula that you guys should know. I'd write it down, memorize it. The magnitude is going to be, I typically am going to put 2 lines down just for magnitude. I like it better. But the magnitude is going to just be the square root of vector 1 squared plus vector 2 squared. Okay? So let's do some examples of that. So in this first example here, they're saying find the magnitude of the vector and write your answer in the simplest radical form. So the vector that I have is going to be vector is 1 comma negative 4. So the magnitude, and I'll just do it as an absolute value, whatever, is going to be 1 squared plus a negative 4 squared, which is going to give me 1 plus 16. And my magnitude is going to be a square root of 17 units. That is how we find magnitude. Okay? This green box that I have here too is an important one for you guys to know. And I'll do all of these for you in just a second, but it's important for you guys to know. All right, so number 4 here says we have a vector m, which is negative 7 comma 0, and a vector n, which is 1 comma 6. And they want us to find what a negative 9m is. So that negative 9m is going to just follow this scalar product. And so all that tells me to do with the scalar product is to multiply by my scalar each of my values. So vector A has A1 and A2, and it's being multiplied by K, so K multiplies with each of the vectors 1 and vector 2. So my M here is a negative 7, 0. So negative 9M is going to be equal to negative 9 times a negative 7, comma, negative 9 times 0. And so negative 9m is going to be 63, comma 0. Are we okay with that? Okay. So then m plus n, so m vector m plus vector n is going to be equal to a negative 7 plus 1, comma, 0 plus 6. So vector m plus vector n, their result is going to be a negative 6, comma 6. Does that make sense? That would follow the vector sum. Okay. The next one they're giving us negative 2a minus 5b. So the way that I would do this is I would find out what each one is first. So I'm going to get a negative 12, comma, 4, and then negative 5b, let's not forget the vector notation, is going to be a negative 30, comma, 10. Are you guys okay with how I got those two numbers, those two vectors? Okay. Okay, then negative 2a minus 5b. Now, since they are, since I did negative 5b, I'm really adding them. So I'm going to go negative 12 plus a negative 30. And then 4 plus 10. Does that make sense? Or do you guys want me to show it so that I show the minus sign when I'm combining them. I could do it either way. I'll do it both ways so you guys can see. So this is going to be a negative 42, 14. Now if I did it the other way, instead of getting a negative 5b, I would have gone 5b, and 5b would have gotten me, how did I get 30? Oh, I multiplied with, I got the wrong number here, I'm sorry. That should be a negative 25. I multiplied with a, so I totally did it wrong. This is going to be a negative 15. Do you guys see where I made the mistake? Yeah. Thank you. Thank you, Oscar. I multiplied with a and not with b. So that would have been a negative 25, and this would have been plus a negative 15, which would have changed my result here. Okay, so that would have given me a negative 37 and a negative 11. Right? Okay, good. Thank you. Sorry I didn't see that. I'm glad I decided to show it the other way. Fallible I am. So this would have been 25 and 15. That's 5b. So then when I go negative to a minus 5b, this is the way that they probably want you to see it. You would go negative 12 minus 25, comma, 4 minus 15. And then that's going to give me that negative 37 and the minus 11. Does that make sense? I just want you guys to be able to see it both ways. So, but using the subtraction rule would have been that second way. Okay? All right, let me do this one with the dot product. Now the dot product is right here. And what it's telling me is to take the A components and multiply them, or the V1 components and multiply them, and then take the V sub 2 components and multiply them. So in this number 14, what's going to end up happening is I'm going to go, okay, if I'm taking the dot product of this, I'm going to get negative 4 times 9, and then 3, oops, it's a plus sign in between, plus 9, why did I run 9? So 3 times a negative 1. So what that's going to give me is a negative 36 minus 3, and then my dot product would be a negative 39. Okay? Do you guys want to try number 15? Okay, try it. Let me know. Okay, cool. So let's do it. So then we should get a negative 3 times 9 plus 8 times 7. So that's a negative 27 plus 56. And what the heck is that? 29? Okay, cool. So it makes sense? All right, good. Well, let's keep moving then. Now, the unit vector, it's called the unit vector because, right, we have the unit circle, and the unit circle has a radius of what? What's the radius of our unit circle? Do you guys remember? The unit circle has a radius of 1, and so our unit vector has a magnitude of 1. So it's important that we know that our unit vector has a magnitude of 1. So it'd be equal to 1. Okay? So, a hat is usually the symbol that's used, and it looks like a little hat on it, but that's just symbols, so you may see that, and so you know that that's referencing our unit vector, okay? Okay, now let's do some stuff with that and see how we can come up with finding the unit vector. So, here we go. We have find the unit vector in the direction. So in the direction of 5, negative 6. And then they want us to find the components. So if we were to graph this thing, right? We'd graph it. There's x. There's y. In fact, since I'm going to go negative, I should write it up higher. Okay, this is the x-axis here. Here is the y-axis. And so my vector along the x-axis is 5. My vector along the y-axis is that negative 6. And so this is the vector of those components, right? So this would be my component vector for 5, negative 6, right? Well, I want to know what the magnitude is of that vector, and I'm going to call that vector v. Okay, so then the component for that vector, or I'm sorry, the magnitude of that vector is why erase is going to be the square root of 5 squared plus negative 6 squared, which is going to give me 25 plus 30, 36, which is going to give me the square root of 62. Okay, so that is the magnitude of this vector. Now, the vector that they're asking us to find is the unit vector, and that thing's supposed to have some magnitude that's equal to 1, right? So in order to be able to make it equal to 1, this is the trick. Are you guys ready? It's gonna be our vector v, whatever our vector v is, divided by the magnitude of the vector v. That is going to give us our unit vector. So I would go, okay, my v is my x component, or my x vector would be 5 over the magnitude, which is square root of 62, comma, negative 6 over the square root of 62. That is my unit vector. If I were to do the magnitude to that vector, its magnitude would be equal to 1. Does that make sense? Okay. Let me do number 10. And on number 10 then, if we want to find the unit vector, I don't need to show you the graph, I'll just do it for you. So what's going to happen is I need to find what the magnitude is, right? So the magnitude is going to be negative 7 squared plus 1 squared over the square root, which will be 49 plus 1, which will give me a magnitude of 50, right? So the unit vector, again, is going to be the vector divided by its magnitude. And so I'm going to get a negative 7 over square root of 50 and 1 over square root of 50. And that's the answer to that one. Is that making sense? Okay, good. Okay, so let me show you some stuff. I want to be able to show you how to find angles and whatnot. So we know now, we've learned some things. We know that if this is our vector v, the components are going to be a comma b, right? We know that the magnitude is going to be the square root of a squared plus b squared. But now we can find the angle also by going tangent theta is equal to my b over a, right? So it's the same thing that we've done with our trig prior, but now we're talking about it in terms of angles. And so to find our theta, we would just go, okay, tan inverse of b over a, right? We know how to do that. So why don't we try a problem and see if we can find the answer. Okay, so here is our problem. They're trying to get us to get the reference angle. They're trying to get us to find the angle right here. Okay, we're obviously in quadrant 2. So let's see if we can find this. So we're going to find everything that we need, right? We need to find the magnitude of the vector. We need to find the angle on the acute side. So we need an angle that's less than 90. So we'll do that. So our vector is what? What are the components for this vector? The 4 is right. Yes, it's negative 7 comma 4. And then to find the magnitude, so our magnitude is 65. We got that. Now to get the angle, isn't that going to be tan of theta is equal to 4 over a negative 7? And here we can do it in degrees. So what did you guys get with your calculators in terms of a reference angle? Pull out your calculators, see what you get. Oh, and in this case, make sure you're in degrees. What? Yes. So we get a negative 29.7448, right, with a bunch more digits. But they want the angle from the x-axis over, right? So the way that the tan inverse gave it to us, it gave us the angle in, it gave it to us in the fourth quadrant, right? Because it doesn't know how to differentiate which way it does it, so it usually goes negative x, and then, I'm sorry, it goes positive and then negative for the y. And so that puts us in the fourth quadrant, but we actually know that we are in the second quadrant, and so the angle should be a positive 29.74 degrees, because the angle is going this way as a reference, and so it should be a positive reference. Does that make sense? Okay, good. We need to be able to do that and get that clearly. Why don't you guys try this one for me, number 13. And then I'll do it. Excuse me. Thank you. All right, are you guys ready for me? Okay, so let's see. So they want us to find everything. So our vector v is going to be equal to, it looks like 8 comma negative 4. Is that what you guys got? So then the magnitude of this vector is going to be 8 squared plus a negative 4 squared, square rooted, which will be 64 plus 16, which is going to give us 780. I could clean that up some if you wanted me to. I could go 2 root. Is that, no, 2 root. Let's see, can I go bigger? 16 times 5. I think 16 times 5 works. Is that right? 16 times 5? That's 50. 630. Yes, I think that does work. Let me double check. I don't trust myself. 80. Good, it does work. Okay. So now that I have that, I have the component, I have the magnitude. Now let's get the angle. And so the angle should be tan theta is equal to, it's going to be negative 4 over 8, right? Negative 4 over 8. So then my theta should be tan inverse of a negative 1/2. And that gives me an angle of negative 26.57 degrees. Correct? And this one is going to be a negative, and the reason it's negative is because we are going below the x-axis counterclockwise. We okay? Okay. Heck, we may finish all of 11 today then, which is cool. I'm fine with that. Let's do, there's only 4 more problems to do. And then we're done with this whole notes 11, which is good. It gives us more time to potentially review. All right. There is a formula to find the angle between 2 vectors. How do you know when it's a negative or not? Okay, cool. That's a good question. So typically what happens is if you're going to reference, and you could have done positive actually, that would have been fine. Just call it, actually, let's go 26.57. But typically what I say when I'm doing reference angles, if I'm above the x-axis, I typically do positive. If I'm below, I typically do negative. But since we know what the components are, we would know it would be a positive reference, and so we could just do the positive reference. But typically, the way I do it is depending on if it's above or below the x-axis. Does that make sense? Okay. All right. So this is how we end up finding the angle between 2 vectors. So what we end up needing is we're going to need the magnitude of 2 vectors and then the dot product of those 2 vectors. So we need to remember what the dot product was. And so the dot product tells us to multiply the 2 vectors. They're each parts, right? So if I had like v dot w, I would go v1 times w1 plus v2 times w2. That would be the dot product, right? The magnitude is just taking what we've done, right? Squaring each of the components and then taking the square root of them. So let's do an example and you guys can see from there and we'll be able to go. All right. So my vmat vector is going to be negative 8, 6. my W vector is going to be 9, comma 8. I'm going to do my dot product. And so the dot product is going to be negative 8 times 9. Ooh, why did I put the vector symbol? Silly. Plus 6 times 8, which will give me a negative 72 plus 48, or a dot product of a negative 24. Okay, I need a couple more things. I need the magnitude of V, and so the magnitude of V is going to be the square root of negative 8 squared plus 6 squared, which is going to be 64 plus 36. That's 100. So square root of 100 is 10. So that is the magnitude of V. The magnitude of W is going to be 9 squared plus 8 squared, which is 81 plus 64, which is 145. Okay, so then to find the angle, I'm just going to use this right here. That's going to give me my angle. So I'm going to go theta is equal to cosine inverse of the dot product, which was a negative 24, over the product of the two magnitudes. So 10 times square root of 145, and then that should give me my angle. Okay? So negative 24, and this is obviously use of a calculator is very beneficial here. And I'm going to get an angle of 101.496563 degrees. But our answer here is asking for an answer to the nearest degree. So, however close we are to 0.5, we're not there. We're looking at the 1. So even though this is a 4, so this stays 101. If it had wanted the 10th digit, then that would have become a 5. So we just missed going up 1 degree. So it should be 101 degrees is that angle. No, because it's to the nearest degree that they're asking for. Does that make sense, Oscar? Okay. Do you guys want to try number 17? See if you can do it? Yeah, okay. Try 17. Let me know when you're ready. Okay, so let me do it, and we'll see what we get. So our dot product is going to be a negative 9 times a negative 7 plus a negative 7 times 3, which will be 63 minus 21, which will give us 42. Is that what you guys got for your dot product? Okay. The magnitude of V is a negative 9 squared plus a negative 7 squared. So that's going to give me 81 plus 49 square rooted is 90, 130. Yep, okay, good. W's magnitude is going to be a negative 7 squared plus 3 squared rooted 49 plus 9, and that will give me 58. Yes? And so my angle should be cosine of 42 over square root of 130 times the square root of 58. And let me see what I get on my calculator. So the theta that I got was 61.07 degrees. And since we want it to the nearest degree, it should be 61 degrees. Does that make sense? It's been a lot today, but it's not too bad, right? Vectors are actually fun. If you understand them, it's very, very manageable. Okay. Let me show you these last two and then we'll be done. Now, one thing that's interesting about this is it says when vectors are perpendicular, something interesting happens. Yes, your calculator should be in degrees. Okay, no problem. So here, when we talk about perpendicular, if V is perpendicular to W, a vector v is perpendicular to vector w, that implies that the dot product of v times w is going to always be 0. Okay? So, if this is my v vector and this is my w vector, what it's telling me is to find what k is to make these perpendicular would be 7 times 1 plus a negative 5 times k needs to equal 0. So 7 minus 5k should equal 0. Gives me negative 5k is a negative 7. So k is 7 over 5. That is what's going to make these two vectors perpendicular to each other. But this here is the absolute key. Okay? Does that make sense? So why don't you guys try number 20, and then I'll do it. Let me know when you're ready for me. I don't know. Let's see. Yeah, I think that's correct, actually. Yeah, I think it is 3/5. So what we're going to do is we're going to take the dot product, and so it's going to be negative 1 times a negative 3 plus a negative 5 times k. That should be equal to 0. So 3 minus 5k is equal to 0. So negative 5k is equal to a negative 3. So k is equal to 3/5. Awesome. You guys feel like you got this okay? Good, good, good. So here's what's going to happen. Yeah, it wasn't too bad at all. I'm done recording, so let me just stop that.